man, nick of time. Oh man, look at that. Okay, sorry, I'm getting confused. Hi everybody, this is Fraser Kane. I'm the publisher of Universe Today, and once again, we're going to have our virtual star party, and I absolutely guarantee this is going to be just a phenomenal night. I can see it already. We've got, so I'll just sort of let everyone know the team that we've got right now. Working the telescopes tonight, we've got Stuart Forman, who's in San Francisco, and he's the one showing this beautiful view of the moon right now. We've got Mike Phillips, and he's in North Carolina, and he's got this gorgeous view of Saturn right now. And these are both live. Gary Gonella, he's down in Los Angeles, and what's your view, Gary?
Pretty good tonight.
Yeah. What was that object in the telescope there?
What we're looking right now is the monkey head.
The monkey head. Okay, great.
NGC 2175. It's in the upper part of Orion.
Perfect. And then we've got Peter, who is in Australia, but he's actually virtually controlling this massive telescope that's in New Mexico. And Peter had you had a galaxy going there, Peter?
Yeah, I've got M101. Yeah.
Oh, that's fantastic. And then for color commentary, we've got Chris Ridgeway. Where are you located, Chris? You're in...
I'm located in Indiana.
Indiana, yeah. And you've got clouds and rain. And we've got Mike Behrendt, and you're in Chicago, right?
Yeah, just outside of Chicago. So I've got the same rain that Chris is getting right now.
Yeah, you guys are sharing the same rainstorm, yeah. And last but not least, we've got Pamela, who is on an iPhone in a hotel somewhere. Can you hear us, Pamela?
Yeah, I'm in Washington, D.C., and right now I'm doing what I hope all the rest of you are doing, and I'm working to try and post this live and share this across Twitter and Google+, and I hope you'll share along with me.
Yeah, absolutely. So yeah, if you want to take a second, if you want to tweet a link. Now you can watch what we're doing. You can watch this on Google+, of course. And if you have me circled, then it shows up in the stream. You can also watch this on YouTube now. There's live viewing on YouTube. And we also will host these on cosmoquest.org/hangouts. And we have a lot of people that always wonder, like, I can never get a chance to see the hangouts. I don't know when it's going to happen. And so if you haven't already, you want to go to CosmoQuest and you want to sign up for CosmoQuest. And then we'll send out a notification that the live hangout is happening. So that's the way to do it. Because a lot of the people, we try to notify people through Google Plus and Twitter and Facebook and all those places all at the same time. So, and look at that, we're going to get Mike at the same time. Okay, great. All right, cool. So why don't we start with the moon, because this is
Fraser.
Yeah.
I have an emergency call right now, so I'll come back. I'll be back.
Great. You just leave it on the moon then.
Okay.
Perfect.
Yeah.
Thanks. Stuart is actually a doctor. He gets emergency calls sometimes in the middle of our hangout, so we have to go and let him fix people if need be. Cool. Well, I was going to start with that. So why don't we start with Mike then? So Mike, why don't you tell us what you're seeing right now?
So I had to join twice, and I'm outside in the dark. So I don't know if you can see me with this flashlight on my face.
Yeah, we can.
Yeah. So I've added color to my routine here. I have a new camera that I'm testing out here, and I think it looks pretty decent. It's mostly average night, but I got clear skies, so I thought I'd take advantage of that. And we're looking at Saturn here. And this is a color camera, so you can actually see some of the real yellow hues in the center part of the disk here. And I have a lot of dust, so pardon the dust here, but.
And you can see the Cassini division.
Yes.
Cassini division, yeah, that's amazing.
That is phenomenal. This is a great camera. Don't ever change cameras, please.
I won't. I'll probably do my final images in the monochrome with the color filter wheel, but I figure this is a lot nicer for sharing.
Oh, that is unbelievable.
What's really amazing is back in 2009, Saturn was at equinox, and that meant that its rings were exactly edge-on to the planet Earth. So when we looked at Saturn, we just saw this straight stripe going across it. And over time, as the planet has orbited, it's slowly been rotating so that we can see more and more of the rings. And right now, we're actually getting to see essentially springtime in the southern hemisphere of Saturn as the northern hemisphere passes towards winter. And the Cassini spacecraft is there orbiting Saturn, trying to catch all of the atmospheric storms that appear in the atmosphere with the changing of the seasons.
And so we're going to continue to see the rings broaden out over the next couple of years, right?
Yes. So the planet's on a 27-year orbit, and so you take 27, divide it by 4, and so basically every a little less than 7 years it starts to switch seasons. So we were at equinox in 2009, add 7, 2016. We're going to be at the height of northern winter, and then it's going to work to flatten itself back out again.
Oh, it's just gorgeous. That is unbelievable. I cannot believe how good this view is of Saturn.
I hope I can get a final
there's
image
like some
for
kind of dust particle on your camera there. Have you noticed that?
Yeah, you know, we get a lot of pollen and stuff all spring long, and I just haven't had a chance to clean it all up yet. So.
Yeah. Now, do you think this same camera would be good for other stuff like star clusters and things like that?
Yeah, probably.
Yeah.
I bought it with the intention of doing some guiding too. So, and I have a different digital SLR that I'll use for some deep sky work at some point. But you know, my clear skies have prevented me from doing any kind of practice on any of this new stuff. So this is actually my second time on Saturn the whole season, and it's already passed opposition. So.
Wow. Do you have a Barlow on to increase your magnification?
Yeah. So my native focal length on this is an f4.5, and this is a 5x power mate on here now.
Dang. Okay. So you can go basically from Planetary Nebula to the American Nebula.
Yeah, pretty much. Once I get the hang of it,
That's
right?
Cool. Right. So basically, put into more English terms, he can go from looking at little tiny things like Saturn here to looking at the largest nebula that are out surrounding us in the galaxy, and be able to take in all the views in between.
Oh, it's just phenomenal. Well, I could just stare at this all night. So why don't we move over? I just want to look at what Stuart's got as well. So Stuart, are you back, Stuart? No, I guess he's not. Well, let's look at the other stuff then too. Okay, so Gary, this was the Monkey Head Nebula, is that right?
Called the Monkey Head. And we found it a couple of weeks ago when you were still on vacation.
That's right.
And I thought it's a nice looking, something
well,
nice to look at.
If you want to see it, you have to turn your head sideways, and then I guess on my screen, I'm not sure if it's what everyone else is seeing. If you can see on the right-hand side, I guess you can rotate it. Yeah, you can see the monkey face there. Yeah, it's over on the right-hand side of that image.
Yeah, that's perfect.
Yeah, that's really cool.
So you can see the eye and the mouth, and it has a stripy bit going from its mouth up its cheekbones, and
yeah.
I see tamarin mane hanging out behind it.
And so what is it, though?
It's just a cloud of hydrogen gas that's being illuminated by a cluster of young stars inside the gas. And like we've said in so many other star parties, when you heat up hydrogen gas, it's one lone electron has a tendency to jump to higher and higher energy levels and sometimes jump off the hydrogen altogether. But when that electron comes back and settles down to a lower energy level, it gives off light with each of its jumps from basically stare to stare. And each of those jumps through the energy level gives off a different color of light. And the brightest color that we see with our eyes is a bright red. So if we were looking at this image in color, what we'd see is this is a beautiful red nebula.
And so how long of an exposure are you doing, Gary?
That's 60 seconds.
That's just 60 seconds.
Yes.
Wow. Yeah, that's phenomenal. And then let's take a look at what Peter's got. And so, Peter, what have you got on your telescope right now?
So M101 is a deep sky object, commonly known as the Pinwheel Galaxy. And this was quite a sought-after subject last year because we had a supernova in this galaxy. that brightened to about magnitude 11, I think, Pamela, if my memory serves me
that
correct.
sounds about right.
Yeah, it was 2011 FE was the name of the supernova, and it's a beautiful galaxy. And I've got a couple of galaxies lined up tonight for you. So
sounds great.
Fraser, I'm back.
Okay, great. You can stick around for a little bit.
Yeah, no, I'm fine. A friend of mine was sick and he called, and now he's on the phone, so I'm good.
Yeah. So we just wanted to gaze at your image of the moon right now. So what phase is the moon at right now?
Right now, I think it's first quarter.
Yeah.
And if you just go outside and look up in the sky, you'll see half a moon, but it's not really half a moon, it's a quarter of a moon. So that's why it's called the first quarter.
And this is really our favorite time for
and so we're
viewing the
looking
moon.
right now at the Terminator.
And what's the Terminator?
Yeah, it's
Apart
mine.
from that,
too,
Arnold.
Yes.
Yeah. Yeah, I mean,
the Terminator, the Terminator is right. It's where the shadow starts and the light ends. You can see on one of the craters, you can see that the crater is in shadow, and that's right at where the Terminator is. And I can pan it right up along the Terminator, so you can see as I pan it right up. Oops, wrong way. We can go all the way to the other end of the moon. And see, there's the other side.
That's great. And so we've said this in the past, right? That during this time is our favorite time to actually view the moon, because you get these really big, nice, long shadows. You don't really want to see them. You don't want to really observe the moon when it's full, because the light is coming straight down on the moon, and it really obscures your view. But it's when you get this light from the side that you get these big, long shadows. And there's one thing that's really cool. I don't know if you can see that. There's one crater there that has the central peak is lit as a little dot of light. I don't know if people can see this on their hangout, but there's like a little dot of light in the middle of the crater there. And so what you get, right, is you get this situation where you got the moon's there, the asteroid comes in and strikes the moon, and the rocks collapses and splashes up from the impact of molten rock and then piles back down, and you get this central crater. And it's really quite fortunate exactly where the light is right now. You can see that little central peak lit. But if you actually look at a lot of these craters, you can see these central peaks all through them. And you get the same situation time and time again. It's really cool. So, so Stuart, do you think you could try putting on that Barlow, and we can look at some other stuff and maybe try to see some of that stuff with an even higher resolution? Maybe that crater that we're talking about right now.
Yeah.
That would be great.
Sure. Yeah. It'll take me a few minutes to get it.
That's
set.
okay. That's okay. I know that Gary's got some stuff as well. So why don't we switch back over and see what Gary's showing us? And we've got Saturn still. We always have Saturn.
Here we go. Let me zoom this down a little bit.
I am totally jealous of Mike and Stuart's views. Mike's Saturn is phenomenal. And
isn't that unbelievable?
When Stuart said he's going to go put his Barlow in, I'm like, I thought he had his Barlow.
Yeah, that's what I was thinking too.
Yeah. For people who
why we
don't know,
share.
the Barlow is like a magnifier, right? So it
Yeah.
takes whatever, you have like a 2 times or a 3 times or a 4 times Barlow, and so it just takes whatever resolution you've already got, and it just magnifies it a certain number of times. So it doesn't give you a lot more light, but if you've got really bright objects, then it can make them a lot bigger, and it's a really great view.
And this
So I
looks
see,
like
what
it's
is
a
that,
little
like
tiny
the-
big planetary
Yeah.
nebula.
Yes, this is the one last week. Remember, the
Yeah.
feed got shut down, and we were talking about that. This is the rotten egg, and it's in the M46 open cluster.
So
now-
this is a star very similar to our sun that basically, as it died, it shed off its atmosphere, and the atmosphere drifted away. But then the very core of the star collapsed down, and it stayed behind as a white dwarf star. And we don't see the white dwarf because it's so small and so tiny and faint. But the outer atmosphere, if we could see this in color, it would have all different colors involved. They're really quite stunningly beautiful. And this is what our sun will do someday.
Yeah, and this is actually fairly small. Would it be about the size of Saturn in the sky, or even maybe a little bigger?
No. Well, in the sky, I'm not.
From our vantage point, in the universe, it's
right.
light years across, but from our vantage point. So
it's about that, because I was looking at Saturn earlier, and it's about that much in the view. And this is also 60 seconds, and it is not binned, so I'm shooting the regular pixels, so I could enlarge it a little bit.
Yeah.
And we can see down to the pixel level of it.
Wow, that's really cool. Now, were you going to show us something else, Peter? You going to cue something else up?
I think he's away from Stuart at the moment.
Oh, is he? No, I know he had a meeting at some point. So, well, then why don't we look at some... Chris and Mark were going to show some pictures that they had captured the last couple of days.
Sure. I've got some stuff here. This is what I'm going to throw up is a picture I took when I was camping last year, and I accidentally caught a meteor going through the screen.
Oh, yeah, I can see it.
Oh, that's awesome. And I assume it wasn't actually going through your screen, but it was going through your field of view. It would be much more awesome if you went through your screen.
Ouch, yeah. But it's cool. It's like a rainbow there, yeah.
It went through my field of view, yes, not through my actual camera.
How long of an exposure were you doing?
I think this was about a 15 to 20 second exposure, so, talk about a real, hole-in-one to get that little streak there.
Was it during a meteor shower?
Nope, it was mid-October of last year, so I don't think there was any meteor showers going on at the time. And
so when you're going to take a picture like this, what do you use? You use your DSLR, right?
Yeah, this is just my Canon T3i on a tripod with a cable release, and I just took some random 30-second images. I was actually trying to get some good shots of the Milky Way, which here's one of the better shots I got of the Milky Way. And I was just playing with the exposures, and I just happened to catch a meteor.
Yeah, that's phenomenal. That's cool. And Chris, you had some cool pictures of the sun that you just took like a couple of days ago, right?
Yeah, I'll bring that up real quick.
The reality with the meteorites is there's shooting stars every night, and there's always the ability to see them as you're standing in your driveways, as you're trying to take photos. But it's during meteor storms that we'll end up getting a good storm. We'll end up getting tens of meteors per minute versus the 5 or 6 per hour.
Right. Yeah.
Can you see that all right, Fraser?
Yeah, I can see that. That's great. And so you can really see there's a lot of sunspots on the sun in your image. How long ago did you take that?
Let's see here. I was thinking this was 2 weeks ago, I believe.
Yeah. Okay. And I mean, the sun is entering its more active phase right now, so there's a lot of stuff on the sun right now. A lot of sunspots on the sun. What's the method that you use to take a picture like this?
Well, this one I used the solar filter film on my 8-inch Meade, and then I just used a DSLR and took this as a single photo. This is just a single capture.
So you didn't do any stacking on this?
No, I tried and failed.
Oh, really? Yeah, you tried to do some video and it didn't work?
Yeah, I tried to do video, and then I tried to stack actually these stills to see if I could get a little better clarity out of it, and I failed at that too. I'm going to try again later, but
yeah.
So this is just a single image. I think it was 1/250th of a second. Probably at I'm trying to think, F100, F200, something like that. I don't remember, or
That's really cool. I really want to get some live stuff from the sun. You had that in one of the hangouts that I missed, right? Didn't you have from Teal was in Australia and was getting some sun stuff? Yeah.
Yes. It's really awesome because the sun right now is so active. And when you look at it, you can actually, if you have the right telescope, see the spots evolving in front of your very eyes. It's hard to imagine something as large as our sun as changing, but the sun is moment to moment a different star.
Yeah, no, it's phenomenal. So how's it coming with your Stuart? I think I saw you with the Barlow at some point there. You're getting...
yeah, give me a minute. I lost it for a second. I'm having a little trouble focusing.
A little trouble finding the moon. That's good. And so...
it's not that easy.
I know. When you're that magnified, right? This is the big problem, right? When you take a telescope and you magnify it so much, then it's actually really hard to find any objects. And so usually what you'll do, right, is if you've got your telescope, you'll use a really wide eyepiece first, and then you'll swap it out and put a tighter one, and then put in the Barlow and hope that you haven't lost the object. So, and then Mike, did you want to try and see if you could get like a star cluster, like a globular cluster or something with that color camera? I'd be really interested to see how far you can push that.
I have pieces of equipment hitting the ground right now, so.
Oh no.
I'm in triage mode for the moment.
Okay, well then I won't make any requests from you.
We'll see.
Oh, there we go. That's really cool. So you can see. So now Stuart's got his Barlow in, and so this is the thing that multiplies multiple times, and you can see.
Yes, it's a 2x Barlow.
It's a 2x Barlow.
I'm not going to push my luck with a 4x one. I have one, but.
Can you try to get closer to that Terminator again, like out on the limb?
Yeah, give me a minute.
But you can see that central peak. I don't know if you can see that over on all these craters. They have these really cool central peaks on them.
Actually, a couple of those things that I think you're calling central peaks, if you look at the side the shadow is on, they're actually little tiny craters inside of the bigger craters. So the way you can tell what's up and what's down is if the shadow is in the top left and the bright is in the lower right, then it's a crater. So that one has both a central peak and a baby crater inside of it. The one that's slightly up center left at the moment. It looks kind of like a bird winking at you.
And look at that line down at the bottom there.
Yeah, I just saw that.
That's probably a fault line where the surface just slightly collapsed on one side and not the other.
Would that have happened before the impact, or would that be after the impact?
That looks like it would be after the impact, because if it was before the impact would have come in, obliterated that feature, and just filled back in with lava material and other.
Right.
Lava on the moon can also mean melted rock that was melted by the impact.
Right.
That it's something that happened after the crater formed.
That's really cool. And what have you got in your view, Gary? Looks like
there we go. I'm unmuted. This is NGC 4038, which is called the Antennae Galaxy.
Yeah.
And there's actually two of them right here. My setup's just not good for this. This is 60 seconds, and it's not binned, so I went full resolution.
Yeah, I can see it's quite noisy, right?
Galaxy here and a galaxy here.
It looks remarkably like a stylized dolphin jumping out of the water.
Well, yeah. And there's tails from both of the galaxies that are crossing. It's a pretty famous
Yeah, it's quite a phenomenal object. I mean, you can see that, like, this great galaxy collision. This is happening all the time, right?
Yeah, I've never tried to image this one before.
Oh, really? This is the first time?
First time.
Yeah.
And so this is very similar to what will happen when our own Andromeda and Milky Way galaxies collide. And what's kind of awesome is both of the galaxies, as they're colliding, gravity is driving dust to collapse into the centers of both of these systems, and it's triggering massive amounts of star formation. And it's also feeding the black holes in both of these galaxies. So right now, both of the galaxies have black holes that are undergoing massive eating binges before eventually coalescing into a single giant black hole in the center of the two systems that will eventually form one large elliptical galaxy.
Fraser, here's the crater with the little central peak poking up.
Oh, that's perfect. Oh, look at that. This is just amazing. Let's see if anybody has any questions for us. And if anyone has any requests, we'll take some requests.
What's awesome about the moon is when you look at regions like this one that are just littered with craters, you're actually looking at some of the older sections of the moon. When you look at the large, smooth plateaus on the moon, those are areas where lava and other things have filled in the older craters. And so that's actually a younger surface that you're looking at.
Yeah, so I'm just reading some of the comments. A lot of, wow, Saturn looks amazing, plus 1,000. Is there a button for that? Can you click the plus 1,000 button? That would be great. Yeah.
Fraser, I'm back now.
Okay, great. And what have you got? What have you got for us?
So this is Galaxy M106, and there's another little galaxy you can just see below that. I can't remember the name of that one off the top of my head. But yeah, it's a beautiful, it's kind of, it's not, there are a couple of different types of galaxies. There's a spiral galaxy, there's a barred spiral, and this one's, some of them you see edge on, some of you see face on. This one's at about a, I suppose a 30 to 40 degree angle on, and it's quite a stunning object.
And it's an interacting galaxy. So in its recent past, something passed past it and disrupted its shape, and this is where you end up with those gentle curves of faint material stretching away from the main part of the galaxy. And when you look at this in other wavelengths, you're able to see amazing structures of light that just isn't visible to the naked eye or to our cameras that are observing in the same colors that our eyes see.
Really cool. And then Gary's got something. I think it's really important for people to be. Hey, did you get an airplane, Gary? What is that? A meteor?
I don't think it's an airplane.
Or satellite.
I'd guess satellite or meteor.
Yeah.
Yeah, that was a 60-second exposure, so it could be satellite.
Yeah, satellite. So you got a satellite, and so the satellite is turned into this line that moves along the image. That's great.
Yeah, I'm trying to see if I can pull anything out. I didn't know if this was going to work or not. This is the Coma galaxy cluster with NGC 4895, and there should be 50 or 60 galaxies that you can pull out here.
Wow.
And I can
one
see
of the
a few of them.
Yeah, one of the issues you're going to run into with a telescope like yours, which is very similar to the one that I used for my master's and dissertation work, is the pixels are so big that a lot of the galaxies are going to look very similar to stars.
Yeah.
Everything, as it gets further away, gets smaller and smaller and smaller. If you see a person on the horizon, they look smaller than the person standing next to you. Well, the same thing happens as galaxies go farther away, and as galaxies get farther away, they look more like stars. Well, if you have really, really high resolution, you can differentiate stars from galaxies to a greater distance, but pixels on this camera are so big that things all start looking one pixel across very quickly.
Yeah, I can see this is a galaxy here and here.
Yeah.
But
Down
I can't
and
really...
straight down, I think you have another one.
Yeah, and there's...
Slightly to the right of where your cursor is.
And this is also a 4x4 bin, so I've got very big pixels.
Yeah.
Now, someone was wondering if we could get M13, but it's still a little early in the season, right? We don't have Hercules up yet, right?
I got a photo of it.
You have a photo of it? Sure, that'll do.
There you go.
We'll take that request. That's great. This is really cool. So if you, I'm just going to go to Peter's view for a second here. So you can see on Peter's view, because he lives in Australia, right, and he's trying to access his telescope from through the entire planet. He's got an all-sky camera, so you can see what the weather's like there, and you can see all the domes in this image all around the horizon there, and so you're sort of in a cluster of domes, right?
Yes, that's right. So New Mexico is one of the dark sky sites in the US. So it's a very dark sky site, except for when that big luminous thing that you can see in the window next to me is up in the sky. So it's kind of it's almost like daylight when you're there with the moon up. So I'm just going to move across to M51 now. So I did this a few minutes ago.
And Mike, you've switched cameras, haven't you? I can see that you're using using black and white one now.
I had to do a meridian flip, and the other one actually hit the pavement, but everything is okay. So.
Oh no!
I actually do prefer imaging on this one, so I figured as long as I had to do some recovery, I thought I would switch to this one. At some point, I'm going to do a nice comparison of color and black and white, but
I think they're pretty close, and the color, it just pops. So you know, if you want my opinion, color, 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 color.
I'll grab a nice sequence of this one, and then I'll try to do a sequence with the color cam. I'll switch back.
Yeah.
One of the tricks for doing really awesome astrophotography.
Let's go back and look at the moon from Stuart.
One of the tricks for doing really awesome astrophotography is to image your object in black and white, like Mike's doing right now, with the highest possible resolution. And then you take lower resolution images with your color camera and basically use that to paint color onto the high resolution images.
Right. So it's kind of, you're kind of faking it, but in the end, the final object looks really nice.
Yes.
Are you getting like clouds in front of it there?
No, I'm actually switching between the filters, trying to find the right exposures to make a full color image with black and white here. So.
Oh, okay. Like in
looks
real
a little
time?
funky. Right, right.
Is that even possible?
Yes. That's why I like this one. It's a little easier to work with.
That's great. Look at those craters. This is amazing. This is, so, I mean, I'm going to go on record. This is the best view we've had of the moon so far, by far.
Yeah, it really is.
It really is just amazing. So nice work, Stuart. That is a great
Thank you.
I think you're.
And I
Oh, I always mention that that's the one that I want. I think I want Stuart's. Telescope. At some point, I will own Stuart's telescope.
Yeah, that's gorgeous, Stuart.
Not that I can ever use it because it's always cloudy and rainy here. But
yeah, I just got back from Seattle and I was pretty amazed. You know, there was sun one day and everybody was just a little too happy.
One day of sun.
So the interesting thing there, Fraser, is you can see that crater. You can see the back limb of the crater lit up in the sun, and just the little central peak sticking up out of the shadow. And as
you can see the shadow of the central peak.
Yeah.
What I like is above and to the right, there's a crater that has another crater inside of it, and the entire outer rim of the internal crater is lit up. So it looks like there's this little glowing donut inside of a heart-shaped pair of craters.
That's amazing. I really want to see the. Are you recording video on this, Stuart?
Oh, I've taken. Well, we've been talking. I'm about on my 10th video, so I'll be able to get something out of this.
That's good because I think this is just going to look gorgeous when you're done. I think this is just going to look phenomenal.
So the moon's different every night because of the angle at which the sun hits the craters, and it'd be a good time for a plug for your million crater count, Pamela.
All right.
Yes, no, that's true. So one of the things that we're doing over on CosmoQuest is we have a citizen science project that we're taking images from the Lunar Reconnaissance Orbiter which these images, we're looking at craters that are hundreds of kilometers across. And with the Lunar Reconnaissance Orbiter data, we're looking at things that instead of being hundreds of kilometers are hundreds of centimeters across. So we're having people measure craters that are 9 meters across and big. And what we're challenging all of you to do is to help us measure 1 million craters and help us map out the moon for scientific purposes between now and when the moon becomes full on Saturday. So log on to CosmoQuest, and instead of playing Words with Friends or Sudoku or Angry Bird, do science while sitting on your sofa watching TV and help us get to that 1 million craters. And all of this data is getting processed by scientists out at Toronto and Southwest Research Institute who are basically going to make sure everything you do becomes a new understanding of this nearby rock that's orbiting our planet.
How many craters are you up to?
So the internet here, as you might tell from my videos, kind of lousy. And so last time I checked, we were over 70,000, but that was a couple days ago. So I'm not quite sure where we are right now. But we need all the help we can get. And like I said, this is real science being looked at by scientists as we speak. And they've already published their first results, which said, you guys are doing it right. So keep doing what you're doing.
Oh, that's great.
How many people are participating right
I do
now?
like the flowing donut. We have a few thousand people right now, all across CosmoQuest.
So they're going to
every
keep
person
working.
helps.
We need more craters.
Yeah.
It's good to give them a goal. Well,
Yeah.
now I don't even know where to look next. There's too many things to look at. What's Gary got? Is that the Crab Nebula, Gary?
Hang on. Yes. That's the crab, and it's very low on my horizon right now. I'm going to show you where the
So the
scope is looking.
The Crab Nebula is a remnant of an exploding supernova that went off and was observed in 1054 by the Chinese. And what's kind of amazing is as we take image after image of this object across the decades, we can actually measure its rate of expansion by looking at how its nebulosity slowly blocks out more and more stars behind it.
And it's very low to the west for me. You can see how low the scope is pointed.
Yeah, you can see your telescope is like just a little lower, and it would be in the dome.
There's actually a top of the mountain that it's going to hit in a minute, too.
Yeah. Well, we've done this in the past, right, where you've tracked an object and, all we get is in your dome.
Yep, yeah. And unfortunately, Orion and Horsehead have fallen into that category now.
Oh, no. So we need some spring objects now. What have we got?
I started looking. I haven't come up with a lot yet, but it's been a busy week for me.
Yeah.
I'm going to see if I can get the Eskimo. I don't know if that'll show up here or not.
What about the Rosette? What about my favorite?
No problem.
No problem or no chance?
No problem.
Okay, great. Yeah, could we get the Rosette Nebula? That would be awesome. I'd love to see that.
You got it.
Every week, I'd love to see the Rosette Nebula. And I was going to show we got some astrophotography. So now this is Mark's version. So, and you can just compare and contrast. So Mark is actually showing us a video, so he's faking it. So I don't want you to feel like this is live.
Yeah, but we're watching reruns here.
Watching reruns, yeah, old episodes.
And what's
classic
cool
episodes of the Moon by Mark.
This is a much younger area on the surface of the Moon. You can tell because there's so many fewer craters.
And so this was a couple of weeks ago, right, Mark?
Yeah, I think about a month ago. The date on the file is April 1st.
But I think it's really important to see that this is a. What's your telescope, Mark?
It's a small Meade ETX 90, so it's 90 millimeter primary mirror, which is considerably smaller than most of the telescopes these guys have.
Yeah, yeah.
But it's great because it's easy to take out to actual physical star parties and not have to make 5 trips to the car.
Yeah, to grab each piece and put them all together. And so what would a telescope like this run a person? Like, what would it cost?
This one, retail I think is about $400, and that comes with the telescope, the tripod, and the hand computer that has the go-to computer on it.
Right, and so this is great. I mean, you can like go and just say, punch in where you want it to go, and then it'll take you right there. So,
right, it
it's
takes me
all in
about 15 minutes to get it unpacked, hooked up, and aligned to where I can start actually seeing things.
And it's kind of the same telescope that you've got, Chris, right? You've got a Meade LX as well, don't you?
Yeah, I've got the Meade LX90.
So you guys have the exact same telescopes. You can see this is.
I have an ETX90, which is a much smaller version of it. I'm trying to get work to give me an LX90 that they have sitting around in the warehouse.
Oh, wow.
The ETX is a Mac Cass, isn't it?
Yes, I believe so.
Yeah.
Yeah, that's a nice little telescope. I mean, I got to say, for a lot of people that are just getting into it, the LX90 or the ETX90 is really a good way to go. I mean, it's, as you said, $400 new, but you can get them sometimes on discounts, on sales. You can get them for even a little bit cheaper than that.
Yeah, I've seen them going for $300 to $350, lightly used.
Yeah, lightly used. And then you can connect up your DSLR camera or
right.
webcam
It's
into it.
like a $50 adapter, so that screws onto the back of the camera. I think Chris has the same adapter on the back. No, that's the right angle on the back of his, I think.
Yeah, I've got the adapter right here, actually.
Oh, okay, great. So how does that attach then? How do you pull that one on?
I don't know how well the scope.
We can see it. That's perfect. No, it looks great.
Basically, I'll have to take this off here. This diagonal right here just unscrews off the back of the telescope. And then what I'll do is I have a T adapter with a T ring hooked up to the back of it, which hooks up to the camera. And that's just screwed in where the diagonal was at the rear of the telescope. And then, like I said, the camera is then hooked up to it. But just like I don't have my camera here with me, but
Right. But the point is that would just connect right up into the camera, and then you'd be set. Yeah, that's really cool. Very cool. Okay. All right. So Gary, you've got the rosette for me.
I do.
I mean, for us. For everyone to see.
Don't kid us. It's for you, Fraser.
For me, yeah. No, I love this nebula. This is great. It looks
And
a little,
unfortunately, this may be the last week, because you can see I'm pointed to the edge here too. So.
Yeah, we really need a whole new set of objects, don't we? Because we're running out of the winter stuff. It's time to look at the spring stuff.
Yeah, this week I'll sit down and come up with a list of stuff.
Do some spring cleaning.
So it's not as clear as we saw it a few weeks ago with it, because it's pretty low in the sky, and it's later than we were too.
Yeah, right. You can really see how, but I mean, you can see the dark dust lanes on it down in the bottom and on the left-hand side of it, and this is it definitely it's weird because I mean I can definitely see that the quality of this image or the quality of the resolution of it is not as good as some of the previous episodes that we've done, and this is just because you've got this situation where the telescope is pointed so far down towards the horizon that you're getting a lot of atmospheric distortion, and so you're just not getting as much of a nice image. And the telescope is trying as hard as it can to pull in that light, but it's just not getting as good a view. So.
Yep,
and what happens is, as the object gets closer and closer to the horizon, more and more of its light gets scattered by the atmosphere, and that changes the color that you see objects. Now, this is a pretty red object, but what little light it has in other wavelengths is now getting scattered by the thick atmosphere it's passing through.
Yeah.
But nonetheless, this is still an amazing object, and when you look at it, dark notches that look like termite paths through the nebulosity. Those are just knots of gas and dust that are so thick they're blocking the light from the background stars.
Yeah, I don't want to take anything away from this absolutely phenomenal image. It's awesome. Any more? We've got some more requests here. What about someone's wanting M3? Can you do M3?
Let me see.
And Scott is saying that there are 85,000 craters they've mapped so far.
Awesome. Thank you for looking it up.
Yeah.
It's so hard to be without a really good internet connection.
Yeah.
So Fraser, I've got M51 here, if you want to have a look at that.
Oh, that's
one
perfect. Oh, that's fantastic.
So this is the quintessential grand design spiral galaxy.
Yeah, this is the classic grand design M51. And so you've got this like little satellite galaxy, a little tail on the bottom of it, right?
Yeah, I'm not sure. I think it's two galaxies in collision. That's correct, Pamela, I think, from memory?
Well, we're not entirely sure if collision is the right word so much as the small one is orbiting the big one, and eventually they will gravitationally merge into a single galaxy, but it's not a violent process like with many other systems. And so right now, that little side galaxy is actually what's gravitationally driving that beautiful, perfect spiral structure in the main galaxy.
Yeah, that's fantastic.
I think this one you can think of as dancing more than violently colliding.
Yeah.
Yeah, it's true. It's got a lot of lovely colours in it. So this is just a 300-second shot in the luminance filter. And as we've discussed before, when you're using a monochrome camera, you take a luminance and a red and a green and a blue filter, and then you combine them together in an image processing package, and then you've got living colour. But yeah, it's a sight even in black and white.
Yeah, no, that's a phenomenal one. Cool. And so, Chris. Oh, and there's Chris. So that's your version, Chris, of the.
Yes, that's the same galaxy there.
And that's with your telescope, the one that we were just looking at.
Right. Yeah. And this is 26 images that have been stacked.
Yeah. So you can see that once if you get a telescope, and even like a mid-range or pretty good telescope, and you get it set up right, I mean, you can gather images, pretty good. I mean, you're definitely not necessarily going to be getting Hubble Space Telescope, but with your eye and with your camera, it's quite amazing what you can get. So, Mike, are we losing Saturn now?
No, this is the infrared, which is actually fairly dim. I wanted to grab one of those, and then maybe we can look at some of the moons of it, and then I'll switch back to color, I think.
Oh, you can actually get some of the moons of Saturn in the view?
Yes. With this camera in particular, I can. Let's see if we can get there we go. Well, let's go back.
Oh, looks like it's a UFO! Look out! No, we know what it is. I'll just go back to the moon. Just stare at the moon. It's so great.
And there's now a completely blasted out Saturn image.
Yeah.
We went from extremes, Mike.
Yeah. That's it. You're our moon guy, Stuart. You're on moon duty. That's fantastic.
Now, Fraser, just while we've got a minute, I might just pop up that asteroid photo I took just as we're getting started. If you can see that there. The little cursor pointing to that asteroid, which you might just be able to detect is as a streak on the photo. It's moving at 3.3 arc seconds per minute, and this was a 300-second exposure. And so you can just see it's just a little bit out of shape as a streak on the photo. That is asteroid 2001 WC47, which is one of the asteroids as part of this new OSIRIS-REx observation campaign that the NASA Goddard Space Institute has asked amateur astronomers to go out and follow a number of asteroids for the next 10 years. Not that we've got anything else to do with our time.
Yeah.
And so there's 70 targets, and they're looking at different categories of asteroids. And they're asking amateur astronomers to feed their data in through some processes they've created with the Arizona University. And there's a partnership going on there. And that's a magnitude 15. And it's going at quite a little clip there. In 300 seconds, it's got about a 9 or 10 arc second streak on the image. So I just thought you might be interested to see that tonight very quickly as well. A couple of beautiful background
stars
here.
It's cool that there's a lot of these,
and,
yeah, it's cool that there's a lot of these interactions between NASA and amateurs, and there's ways that amateurs can contribute to science and at various levels. So the stuff that Pamela's doing, right, people can count craters on the moon, and you don't really need anything more complicated than just you know, a computer and access to a CosmoQuest account. But you can take it to the other extreme, and if you've actually got a telescope and you're able to do spectroscopy or brightness, or you can do you do a lot of variable star work, right? So there's a lot of these kinds of projects that people can work on.
So on the 2nd of May, the 365 Days podcast of astronomy, I'm going to go through a podcast on how to collect that data and what the program's all about.
That's awesome.
Oh, great.
And one
great.
of the great things about variable star
Mike, you were going to try and get us the moons? I think we're still seeing UFO Saturn, but
UFO Saturn. Well, so just so you know what we're looking at here, I'll play with the exposure here.
I think I see the moon.
Yeah, so there's Saturn. This is an illuminance channel, so this is in monochrome, right?
Yeah.
And you can see the rings. You can sort of see the Cassini gap, but what you notice, though, is that it jumps around a lot more in the full spectrum of colors here. But when I slide the exposure up here, it starts to get more and more washed out. And then right about the 2 o'clock, right in the elbow between the planet's disk and the rings, there's 2 little moons. I don't know if you can see my cursor.
Yeah, I see one there.
Right
yeah, I
there.
see them.
Yep, there's 2 of them there. I'm not sure which ones they are. And they jump around a lot because it's a long exposure, so it smears, and it's also mostly average seeing right now.
Yeah.
Those 2 inner ones are usually hard to find, and my guess is it's Enceladus and Mimas, maybe? I don't know.
Would Titan would be a lot brighter if it was in frame,
It
right?
would, yeah, and maybe I'll put the other camera, well, I'll put the color camera in now, and we'll see if we can do it without magnification first.
If the color camera's okay.
Yeah, it does work, yes. It's on the guider right now, so phew. I think I wrapped my cables a little too tight, and the tension pulled it out. So I'll go ahead and switch to the other camera then. We'll use a low magnification to start with.
That's cool, yeah. And so for people who are wondering why we're having to do this, right, that Saturn is so bright that the light that for the camera, you have to modify the brightness of the camera. So you can either look at the planet itself and see features on the planet, or if you want to really boost up the brightness to be able to see these much dimmer moons, then the planet washes out. So with this, and we were doing this with Jupiter as well, you either get the planet or you get the moon. So you can't kind of get both at the same time. And so that's just some of the realities. Are you able to get Phillips and Deimos when you're viewing Mars?
It was tricky, but I did.
Have you been able to get them?
Yeah, I did, and they're laying around on my hard drive somewhere.
Awesome.
I actually think Roy helped me find both of them with maybe a 3rd star in the field there to kind of reference everything up. So I'll have to figure it out.
That's very challenging to do. I wouldn't have thought that it was easy to do given your weather.
Right. Yeah. Hey, I think there's a 3rd one right here.
Size.
Oh, yeah.
Yeah, showing up as Tethys, Dione, and Enceladus in that area.
There you go.
Well, there you go. Cool.
Let's see. I'll up it a little bit more.
Yeah, so it's really blowing out. Yeah, I can see. So there's 3 moons there in the scene in the upper right, just above Saturn.
Right.
Oh, it's phenomenal.
I'm going to switch to the color cam.
Oh, are you gonna pop this camera out and then put the other one in?
Yeah.
Okay,
Yeah.
cool. Yeah.
Yeah. One at a time. It's only one scope. So.
Okay. All right. Well, I'm just gonna go back to the moon. Look at that.
See what I've got here.
Oh, there you go. And so it looks like a Lego, the bottom of a Lego or something inside that crater. Like
That's actually pretty good timing. The Google Lunar X Prize Moon Bots project for teenagers is getting ready to get started. So Lego Moon is on everybody's mind because they're using Lego Mindstorm robots.
Oh, there you go. Fantastic. And Gary, what have you got queued up there?
This is the request for M3.
Hey, you were able to find M3. Oh, that's awesome.
Yeah, and this is not stretched out. It's no binning, so you can start to see the center, but to see more of the detail and more of the stars on the outside when I start going this way.
Oh, here it comes.
That's what I'm used to.
Yeah.
So this is a cluster of thousands of stars that are all among the oldest easily detectable stars in the universe.
And actually, you know what, Gary? This is the first globular cluster that we've shown in these hangouts.
Yeah, it is.
Yeah, we keep waiting for M13, but it's great that you're able to get M3.
And M3 is the one that looks most like a daddy longlegs that had a really bad day, because there's these long, thin trendles of stars that come off of it, and it has this tight core. M13 is a much more extended cluster.
Yeah. Well, that's great. Well, I think we're starting to kind of reach the end. I think we've had a chance to see everything that we're going to see. So I think we'll see if anyone has any more questions, any requests, and then I think we'll start to wrap it up. So has anyone got any requests they want to see? We got M3. You wanted M3, we got M3. That's perfect. Mars. Can you get Mars again, Mike? Or is it sort of...
it's behind the trees for me.
It's behind the trees now? Yeah.
Pretty low, yeah.
Yeah.
Sorry.
We'll do Mars next week. Now you've got a reason to come back.
Yeah, earlier.
Yeah.
Oh, there we go. Okay, so I can get a nice low magnification. I think I can get all the moons here. Just give me a second to focus it up, and then I'll
All right.
Awesome.
switch it over.
We'll just go back to the moon.
So while Mike's finishing up focusing, just to let you up on some new things coming. We should be recording an episode of Astronomy Cast tomorrow, presuming I get off the airplane on time. Flying, you're never sure you're going to land when you should.
Yeah.
But we do have on the schedule recording Tuesday instead at 2 p.m. Central Time, 3 p.m. Eastern, noon Pacific. Wednesday, we're going to be hosting some folks talking about how they make beautiful Hubble images and the basically social science that goes into making artistically images that you just want to spend time staring at. So that will be at 4 p.m. Pacific, 7 p.m. Eastern. If you get our newsletter, it presents all the different time zones in it, or at least a link to all the time zones. And then Thursday morning, as always, we're going to be doing our weekly space hangout. And we encourage you to come join us and then go online at CosmoQuest and do science. So learn, do, and together we'll explore our universe.
So I'm seeing 4 moons.
I see, yeah, Titan is the big one on the left. There's that grouping of 3, and I think the third one is hard to spot with this camera, right?
Yeah, so maybe it's
inverted now.
5
and then there's
moons.
one more out to the right, yeah.
Yeah. That's fantastic. Now, can you bring the brightness down, and then we'll see them disappear, and then you'll see Saturn dissolve?
I think I have to drop the feed and then bring it back in, so just give me 1 second here.
The one to your right will be Venus.
Yeah.
Okay.
So, actually, can I bring it in this way? No, I can't. Okay.
I miss the days of a simple dial U-turn.
Right.
Like, where's the menu option?
Yeah.
You know, interestingly enough, we talk about how a camera can see the dark, deep sky objects better than the human eye. But this is an example where if you look at this, you can see the planet and its moons with your eyes.
That's right.
So
Yeah.
the range of the human eye is phenomenal. It's far more than any camera can ever do. It just can't take long exposures.
Well, and the thing about the human eye is we have a logarithmic sensor built in, and if you were able to rescale these images to be a logarithmic stretch instead of a linear stretch, you'd be able to see something similar, but you're right, the detectors just don't have the dynamic range the human eye has.
Well, I'll just go back to the moon while we wait. We always have the moon. So,
And Mickey Mouse crater right there.
Oh, yeah, there it is. Don't you mean generic mouse?
Right.
We don't want to get sued. I don't know. Do they have the copyright on the Mickey Mouse?
You know, I think the moon came first.
The moon came first. Yeah.
Yeah, but Disney filed the patent first.
Yeah, that's
the patent
true.
before the moon did. Yeah.
I can see the little copyright symbol in the bottom right.
Oh, there's Saturn, perfectly green, just like I remember it.
Right.
So what was this? We had what was it? Venus was purple a couple weeks ago.
That's right. Yeah.
Now we have Saturn is green. You guys are just into a Technicolor alternate.
Just try to spice the show up a little bit, Pamela.
Yeah.
You know. And I actually think Stuart and I share the same camera, and maybe it's a little quirky when it gets into the Hangouts here, because that's definitely not the color we saw before. It was a nice yellow color before, right?
Yeah.
I don't know what happened.
It's still beautifully focused.
Good.
It's just paying tribute to Kermit the Frog. That's all.
Well, I think we'll wrap it up at this point. Then I think I will go on record as saying this is one of the best nights we've had. I'm really, really excited. We've had this gorgeous view of the moon. Definitely one of the nicest views of Saturn we've ever had. A new cluster, which we've never seen a globular cluster before. We watched an asteroid move through the field of view, so I'm just really, really pleased. So thanks to everybody who joined us tonight. Thanks for watching, and thanks as always to the astronomers who have dedicated their time and are out in the cold, although it's kind of warming up now, giving us this great view of the night sky. I really appreciate it from everybody. So thanks again, and we will see everybody next week.
Thanks,
Bye,
everybody.
everybody. Thanks a lot.
Night.
See you.
Thanks.
Bye.
Good night all.
Bye.
Thank you.
Signing out.
Bye.